Polygon made a big announcement that absolutely nobody could have seen coming unless you pay attention to literally anything.
Anything at all.
Anything at all, yeah. Okay, so you were actually there. Do you want to give a little breakdown of what Polygon is doing, what their announcement was?
So I went to the Polygon Connect event, which was like a very interesting one to attend. And the Polygon, like the T-shirts that they gave out, literally said zkEVM on the back. It's like, I wonder what they could be teasing. They're like, big announcement coming on Thursday. We think this could change everything. And it's like, you think it's a zkEVM? So what is zkEVM? So just like backing up really quickly, like super high level, like zero knowledge proof thing. So zero knowledge proofs are...
So real quick. zkEVM is 5 different letters that is 2 acronyms combined. ZK, zero knowledge, EVM, Ethereum virtual machine. Zero knowledge Ethereum virtual machine. zkEVM. That's what it is. Let's get into the ZK first. Zero knowledge.
So zero knowledge proofs are like an area of like math and computer science that basically refers to like being able to prove something without revealing like the full detail of all of the information, right? So this in practice provides a couple of like things for blockchains broadly. So number one, you can generate like a proof, for example, that like someone sent you 1 ETH, right? And the size of that proof will be much smaller than like just in pure data terms than the size of the same transaction fully written out like in a verbose format like on the Ethereum blockchain. So it's a compression thing. It makes it more scalable because there's just less data going on chain. You can prove that your ETH balance should be 1 ETH higher and that someone out there's ETH balance should be 1 ETH lower, but like you're able to compress that sort of thing. It gets bigger when it comes to things like DeFi and like more complex transactions, but like one thing that it provides is like scalability effectively through that kind of compression. Another thing that it can provide is a sort of like transparency or privacy, right? So zero knowledge proofs, you could say, okay, this address here has 1 ETH. These 8 addresses there all have some balance that's gone up and down in ETH. You can prove that like one of them sent an ETH, or collectively 1 ETH should go to this one, then collectively 1 ETH should be taken from these ones. You don't know exactly who's sending to whom. Okay. It's just like a layer of privacy because you're not revealing the full details of the transaction. So zero knowledge proofs are like a very, very promising way to scale Ethereum because, as you know, like the Ethereum blockchain has like relatively little block space available to it. And so any kind of compression we can get is a good thing for scalability and like decreasing gas fees and all of that, right?
And so people have been working on ZK or trying to find solutions for this and even built solutions for this that are live now for, a while now, like years.
So, I mean, two worth noting are like Polygon. They acquired a company called Hermes, Hermez. And they were working on this like zkEVM. So just jumping quickly into EVM, Ethereum Virtual Machine, a lot of the existing efforts on zero knowledge proofs like don't fully just like natively support the Ethereum Virtual Machine, and so they only support like a subset of kinds of transactions, and it winds up actually being much more difficult for developers to build on them than it would be for them to just build on like another layer 1 like Avalanche, right?
Yeah, so the EVM is basically the machine, like the virtual machine, like that Ethereum inhabits, right? So all the apps run on the EVM. So EVM just means that, like, if something else is EVM compatible, you can run the same apps.
Yeah,
there,
you can run the same code,
right?
The same functions, right? It's just like the base set of functionality that like the blockchain supports.
Right, and none of the original or the previous zero knowledge solutions have been EVM compatible, right? So you had to either write in a complete, like, what does it mean to not be EVM compatible? Does that mean you have to write in a different language? Like, what is the big hurdle? As somebody who does not actually do this myself, like, how difficult is it to learn, like, the previous, like, ZK native kind of virtual machine and the language and all that kind of stuff?
It's a good question. I mean, there's, I guess like the primary one that comes to mind would be Starkware, right? And they have like a separate programming language called Cairo, which is really, really
Right.
complicated to write apps on. Like just having like dug through the docs a little bit and like looked at like how you even go about writing these things. Solidity is like the language that you write most like EVM contracts in, and it's like writing, English, right? To write something in Cairo for Starkware, like it's like actually writing like computer science, sorts of like code. Like it's way more complicated.
Interesting.
It appeals really to like people that are like very heavy in like math and like CS research, because it's like much closer to like a pure language, something like Haskell. In like the traditional programming world, which is just like the one that like all of the like real nerds love. But like generally speaking, like you're never going to choose to write that unless you absolutely have to. It's much more difficult.
Right.
There's also like other ones, like I think Arbitrum supports like a subset of EVM actually, which is like kind of interesting, even though they're not zero knowledge proofs. They don't actually.
What does that mean exactly?
Arbitrum, like if you have like certain functions that you're calling like native functions in Solidity, like you might have to rewrite your apps to like not use those functions if like they're not supported by the Arbitrum like environment, just because they like don't have full EVM support. So they don't support like full EVM support would mean that like you can copy paste your code pretty much directly, right, without having to worry about like whether or not the underlying functionality. Oh, I went into night mode here. Dark mode, here we go. Basically, you can just port your apps over, right? Like you have the same contracts, you deploy them here, you deploy them over there. It's basically the same. All the same like functionalities are available to you. With like previous like iterations of zero knowledge proofs, like you just haven't been able to do that.
Okay, I see. Got it.
So here's the thing about Polygon
zkEVM. How big of a deal? Yeah.
How big of a deal is it?
How big of a deal do you think
the whole
this
world
is?
wants to know that, right? So Polygon token was up like, I think it's up like 80% over the last like few weeks, like since the lows, right? Like, and like it was up like 30% like on Monday alone, right? The issue here is that like today people don't care that much about scalability, right? Gas fees are really low. So if you have like a scaling solution, like it doesn't actually accrue that much value to you. Moreover, it's very unclear whether or how this is going to impact Matic's token at all. And so it just like wasn't like a great like press release, right? Like they just, I don't think they thought through like exactly how, to spin this so that like it would encourage people to believe that yes, indeed, there was going to be value accrued to the Matic token. So from my perspective, like that's one aspect that they kind of like could have done a better job on. From another perspective, and I think this is like slightly more important, right? We're getting really technical now, but like fuck it. There are two kinds of zk proofs. So there's STARKs and SNARKs. With SNARKs, you have to use something called a trusted setup, which like indicates that you trust the like. Okay, so when you set up the like Stark like system, you have two parties and they each generate like a private key, and then they have to throw away those private keys. That's the only way that you can have any kind of like sense that like of security, because owning.
How do you verify that?
You can't.
That the private key is thrown away.
You can't verify destruction of information, right? It's just like fundamentally not possible in information theory, right? Like even in a black hole, right? Like there's information that like this is like Hawking radiation, right? Like there's like big Nobel Prize situations. You can't act like there is no destruction of information in a black hole, which is absolutely nuts, right?
So what are you doing when you send something to a burn address? You're not destroying it, but what are you doing?
So a burn address sends it to like a public address, actually 0x00000000. If anyone ever had a private key that would allow them to access that address, they would actually have. It's just an address like everything else, right?
Interesting.
Yeah, it's really interesting.
Okay.
Like broadly speaking, that's how it works. Got it. The thing about this trusted setup is like imagine there are like two computers, right? Each of them has a private key. you need to trust that they threw away those private keys. Otherwise, they can print tokens out of thin air if they hold one or both of those, and either one of those is sufficient to generate tokens out of thin air, with no way of proving that like that was an invalid transaction.
Interesting. Okay,
Yeah.
I see.
So you
Well, I
place
don't
a
see.
lot of,
I mean, I'm just
you
trusting
place a
you.
lot of trust in the Polygon team if you're going to start like accepting their zero knowledge proofs.
I see. Okay, so you're basically trusting that they are getting those private keys or disposing of them.
So there's something called like a ceremony when they set this thing up, and you're trusting that they have taken away their right to God mode, which is like for any human a really difficult assumption to make, right? Like literally playing God is like pretty kind of appealing, and it's like, look, in a lot of cases in crypto, you really have to be concerned about the worst case scenario, right? It's very adversarial, and the worst case scenario, it doesn't look great, right? It's not a great outcome because you do,
Definitely not a cult.
It's not. And look, moreover, like Polygon's a large organization. I'm sure there's somebody that I'm sure within Polygon somewhere there will be someone who, if they wanted to, could recover that private key when it gets like destroyed. In reality, like I think we just have to make this assumption about our fellow humans. Like it's just human nature to like maybe they don't even use it, but someone's holding on to that, right?
Absolutely.
That's my 2 cents on this. So I just like don't trust that, right?
Very reasonable.
It's not even that I don't trust it. I don't want to trust people. That's kind of the whole point, right, of the space.
That is basically the whole point.
Yeah, and now so the issue is that like the other version of zk proofs, like STARKs, right? Like they're way less efficient. They don't compress the data as much. The research is still like probably years away from anything that's really like high quality production ready. At least with like for a full EVM compatibility setup. So I just don't see this playing out. Look, maybe it'll pump. Like, look, the Matic token pumped, right? Like, never fight the narrative, right? But I would be very, very careful. Like, I'm concerned about this, right? Because people are going to start honoring like tokens that were provided to addresses from the Polygon zkEVM. And like, if there is an ability for these guys to like print tokens, then like that could create like an issue where like you have more than however many supply of whatever token on the blockchain. It's just not great.
Like if Polygon was going to be a malicious actor, you're saying?
Yeah. And so like I just don't know that like, for example, like a centralized exchange could take on that risk, right? Like if I were running one, I would be concerned about like the same way like I would be concerned about like any tokens that have touched Tornado Cash. I would be like really having to do a lot of due diligence on before I allow them to like sell. I would feel the same way about Polygon. I might even require that like whoever like sends me the transaction that generated that hash and the state change, right?
So is there a way to get to a more decentralized form in the way their solution is structured?
No, it's
or
just
is
SNARKs.
it just going to have to be this way?
Right? Like they're working on.
Okay, so all
they're
SNARKs
working on Stark-driven like tech, right? But like I just think that like the like fundamentals of the math and computer science are just like not really there yet.
Okay, so you're saying it's a nothing burger. That's what I'm hearing.
And moreover, nobody cares, right? Because ETH is like pretty scalable as is, right? Yeah.
We just spent 20 minutes on it, so I would beg to differ. Okay, nice. Polygon. Very interesting.
None of this was financial advice, legal advice, investment advice, or any other kind of advice. If you're looking for advice, you are definitely in the wrong place. Until next time, stay decent.